Early morning hustle. Hopefully y'all thought that was it is early morning. Welcome back. You can do this. All right, so we want to do categorical data analysis. Okay, of course, chi-square test of independence. Okay, this situation is a tad bit different, and every quarter I teach this. People get confused with the chi-square test of independence and chi-square goodness of fit test. One of the biggest difference between these two techniques is that the chi-square test of independence requires you to look at two variables, one, two, and then chi-square goodness of fit is just one. It's just one variable. All right, so let's go ahead and read the description, SSVA, Summary Statistics Visualization Analysis, and come on back. Okay, so West Coast Grocers, a popular chain with 15 locations across San Diego County, this is not a real store, is analyzing their customer shopping pattern to optimize staffing and resource allocation. Okay, so you already know this is important. The company recently invested in a curbside pickup system and wants to understand if shopping behaviors differ between weekdays and weekends. During April 2024, they randomly sampled 800 transactions from their point of sale system across all locations. Okay, so they want to see if the time of the actual day, weekend or weekday, has an impact on individuals using curbside system or not in the month of April. Okay, they're looking at 800 transactions. Okay, the analysis aims to determine if there's a relationship between when customers shop weekday versus weekend and how they shop traditional in-store versus curbside pickup, and see if they should maybe change the way they allocate resources potentially. Okay, so this is good for that. So this is not a contingency table. This is just presenting the data. So let me actually show you what a contingency table looks like. So here, let's do it like this. Boom. Okay. This will be week. It doesn't matter the actual order. We're going to do weekday. This will be weekend. And then here, this is going to be in store. And then this is going to be curbside. Okay, so in-store weekday, 280, in-store weekend, 240. Okay, so in-store gets lots of purchases, it looks like. Curbside weekdays, 120, and this is 160. Okay, and so what we want to do is find out if the relationship between these two variables are independent or not, aka meaning that they are dependent. Okay, if they're related in some way, shape, or form. Because if they would be independent, regardless of weekday, weekend, we should see the same pattern. Okay, or in-store versus curbside, we should see the same pattern. Okay, and so what we're going to do is test for that. Okay, and so what we're visualizing in chi-square goodness of fit test, I didn't say that was a bar plot, but that was a bar plot, and this is a bar plot as well. Okay, this is a bar plot as well. However, how many variables do you see here? This always tricks people up. How many variables do we see? If you said two, good job. There's two variables. One variable is going to be the day, time of day, and then color is going to be the actual method, whether they went inside or they went to curbside. Okay, so this is a bar plot. Okay, and you see on the y-axis we have the frequency. Okay. Oh, that makes sense. I'm gonna make this smaller so I can see the analysis. All right. So this is my test statistic. This is my degrees of freedom. I'm gonna say this, and then you're gonna see this later on in the video. But the way I get my degrees of freedom is going to be the number of levels of my rows. Okay, minus 1. So the number of rows I have is 2 minus 1 gives me 1 times the number of columns, okay, which is 2 minus 1, okay, which gives me 1. So 1 times 1 is 1. You'll see it in a moment. If it's kind of tricky, that's fine. You'll see it in a moment. Okay, so that's that. and my p-value is 0.003. And so we already know what we should do to our null hypothesis here. We don't know what the null hypothesis is right now, but we know we should reject it because it's less than 0.1. We have extremely strong evidence against it. We have very strong evidence against it. Okay? And so why does research matter in real world terms? Why does this matter? Why do we even care? You can imagine, again, being a boss where you're trying to figure out, okay, where should I allocate resources? Where should I schedule, certain time for me to have a number of workers to work the cash register? There's a lot of reasons why this could be very important. Staff scheduling, okay? And so that's huge in terms of, working with, or handling our managing a store, okay? So in terms of variables, we have two categorical binary variables. Traditionally speaking, one could be categorical and the other one could be categorical binary, or both of them could be just categorical. But in this particular situation, we're looking at two categorical binary variables. They just have to have a categorical in it. One is going to be curbside and the other one's going to be curbside versus in-store and the other one's going to be weekend versus weekday. Again, we have two variables, and we're seeing if the time of the day has an impact on whether someone selects in-store versus curbside. So the observational unit should be just a customer who shops at the store, okay, or individual transaction, not customer, a transaction. It's transaction slash customer. Let's do that, transaction slash customer. And then our population is going to be all transactions slash customers at the 15 stores. Okay. In San Diego. This is it, in San Diego. I thought it was going to automatically increase. Make it uppercase. I guess not. All right, it's fine. All right. And so, again, the reason why I like to make this generalization, so make the specification so that we can understand what we're making the generalization about. So what's not to say inconsistent, but what's not to say clear is how do they select the stores, the transactions from each store, because that could be another confounding variable. That could be definitely a confounding variable in terms of the where people shop. The sample is going to be those 800 transactions slash customers. Sorry about that. From April 2024 across 15 locations. The reason why I didn't emphasize April 2024 because I'm trying to make generalizations about the store in general, not just April 2024. So this is what makes it, again, a convenience sample, and it's hard for us to actually you can't necessarily know all transactions based off of any particular time point. So we're just specifying just April 2024. Okay, so we're not manipulating anyone in any shape, way, or form. So this is just an experiment. An observational study. Sorry, wow. It's just an observational study. All right. We're just observing the behavior of our customers. And then again, we should do a chi-square test of independence to see if these two variables are related to one another. Okay. One of the biggest things that indicates that we're doing a chi-square test of independence is that we have two categorical variables. All right. And our question, and more specifically, or more importantly, is our question is if these two variables are associated or not. Okay. All right, so a lot of tongue twisters. Okay, so now we're ready to actually provide the null and alternative hypotheses. So I want you to take a moment and answer this. Try your best to answer this question based off what we experienced in the past. So now, in terms of categorical data analysis, both techniques, chi-square goodness of fit and chi-square test of independence, all you can do is a hypothesis test. You cannot do a confidence interval. So that's important to note here. All right. And so in terms of symbols, there's no symbols for our null hypothesis. All we can say is that there is no relationship between, or no association between these two variables. Okay, there's no association between these two variables, aka these variables are independent. More specifically, in the context of the problem, is that there's no association between shopping day and shopping method. Whereas the alternative hypothesis would be what? There is an association. There is an association between shopping day and shopping method. These variables are dependent. Okay? There's only two assumptions, of course, random, and then there needs to be at least 5 observations within each cell. When I say cell, I'm referring to these components. There needs to be at least 5 within each one of these cells. Okay, that's us meeting the assumption. I'm going to mention how I calculate this test statistic in class. But this is the test statistic. Remember I told you I'm going to re-explain the degrees of freedom. So there's 2 rows, so -1. 2 columns, so it's 2 minus 1. So 1 times 1 gives us 1. So number of rows minus the number of columns. Let me actually write that out so you can see it verbatim. Number of rows minus 1, and then number or times number of columns minus 1. Our p-value is really small, right? So therefore we should do what's our null hypothesis? Reject it. So based off of that, we should potentially provide resources differently, right, to curbside depending on the actual date. So we shouldn't treat weekend and weekday in terms of the methods in the same fashion. We should probably allocate more resources in the weekday to in-store purchases. Both we should probably do more in-store. On the weekends, we should anticipate curbside to require more effort. Okay, requiring more effort. So you may want to shift your resources. All right. So this is again this is a lot, but all right. So we're going to reject the null hypothesis, indicating that these variables are dependent upon one another. Okay, and so there's some things to know. Just staffing. Should optimize these with different patterns. One of the things that I'm not necessarily seeing here is that, and we're not going to analyze in this level of this class, but I would want to potentially see if this is the same across different types of stores. Maybe there's some stores that are next to other stores, let's say next to shoppers, I don't know. And then some stores that are not next to shoppers, and analyze that as well. We won't be doing that in this class, but that's more context, more, further thinking on this particular model, or based on this particular technique. Is that it? Oh no, I wanted to talk more. I had more ideas. Well, thank you for watching. Have a great day.